This is the class lesson for section 3.5, part 3, and these are transformations of functions. And we'll go ahead and start with number 1, identify the transformation, make a table for the transform points, and graph the function. I'm not going to make a table, but I will write an expression for the transform points, okay? So our parent function for all three of these, number 1, 2, and 3, of course, is x squared. F of x equals x squared. Let's go ahead and plot a few points on that parent function. So we have 1, 1, 2, 4, and 3, 9. And just kind of, we'll be able to see the comparison of the transform function. Okay, so what we have here, we have the number 2. We have a vertical stretch by 2, which makes it a narrower graph. Okay, so our xy on our parent function will now be x 2y. So when x is 1, now y is 2. And when x is 2, y is now, when we will take all of the x values and keep them the same, but we will multiply the y values by 2. So the y value for 2, 4, instead of 2, 4, it's going to be 2, 8. And likewise for negative 2, be 8. So as you can see, we have a much narrower graph. Okay, so all of the y values are twice as large. Let's go ahead and look at number 2. Here we have a vertical compression by 1/2. And here the graph will widen. The graph of the parent function will widen. So let me go ahead and graph that parent function again. 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. It's just nice sometimes to see that parent function graphed along with the transformed function. So I probably should have put that on here. This was g of x. And now our new graph we're going to plot, the transform graph, will be k of x this time. Okay, so now we're going to take half of the y value that we had before, but leave the x value the same. So let's write that here. We're going to have x, y, and now we'll have the same x value, but we're going to have 1/2 of the y value that it was before. So when x is 0, of course 0, but when x is 1, now the y value is 1/2. 2, the y value was 4, now it's 2. 4, it would have been 16. 4 squared is 16, and now it's 8. So as you can see, it has greatly widened. So we're going to have 2, that original graph, I didn't really graph it properly, but it's okay. So negative 4, 8. So now you can really see that it widened, okay? This time, let's go ahead and rewrite this as 1/4, and let me show you why. This is 1/2 squared times x squared, which is 1/4 x squared. So now we have a vertical compression by 1/4. So it's even wider. All of our y values are now 1/4 of what they were on the parent function. 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. So as you can see, I graph these just like you do. And that is f of x. And now and this was k of x. Now let's go ahead and graph h of x. So we're going to take a fourth of the y values. So that'd be 1 1/4, negative 1 1/4. Let's go on to 4. 4/16 is on the graph of the parent function. So now it would be 4 4, negative 4 4. So now you can see how much wider this graph is. And this is h of x. So those vertical compressions actually make those graphs much wider. Okay, we're going to be identifying the transformations, and then we're going to go ahead and make a table of the points. Okay, so in this first one, as you can see, the parent function is y equals x squared. Okay, and let's just give a few points on those. Negative 2, negative 1, 0, 1, 2. Square that, and there we have it. Let's go ahead and graph a few of those. It looks something like that. Okay, now what has happened to this function? What were the transformations? The first one, as you can see, we had a reflection across the x-axis, and then we went to the right 1, and then we went up 4. So what we're going to have is the reflection across the x-axis is going to have the opposite of y, then we're going to add 4. Moving to the right 1, we're going to add 1 to our original x values. So that makes it pretty nice. So adding 1 to negative 2, 0, 1, 2, and 3. So all of these x values I just added 1 to. Okay, the y values, we're going to take the opposite of them and add 4. So negative 1 plus 4 and negative 4 plus 4. Okay, let's go ahead and graph that. Negative 1, 0, 0, 3, 1, 4, 2, 3, and 3, 0. So you can really see that the graph was reflected across the x-axis, moved to the right, and then was shifted up. So really, really a nice sketch. Okay, let's take a look at this next one. Here's our parent function, the absolute value function. And let's just put a few points on here from that parent function. I really would like to keep the colors the same. And we'll do the same thing, negative 2, negative 1, 0, 1, 2, and the absolute value of those numbers. Let's go ahead and have a nice quick plot. And we have that beautiful, graph that is the V for the parent function. Okay, and that is, I'll call that f of x, okay? Now, we'll go ahead and write down what these transformations were. And so what we did here is we had a vertical stretch by 2. And then we went to the left 3. So the stretch by 2 affects the y value. Actually, I would like to do something. I hope that this is okay. I think I want to put a negative in front of this 2. So I'm going to make a vertical stretch by negative 2. So hopefully you're seeing me and hearing me do that. So I want to make sure you see that. So vertical stretch by negative 2, we probably need to change that. It's a vertical stretch by 2, and we will reflect across the x-axis first. Okay, put that together. So the reflection is the opposite of y, and then a vertical stretch by 2, we would have to multiply it by 2. So a negative 2 times our y values. And going to the left 3, we will subtract 3 from each x value. Let's go ahead and subtract 3 from each x value first. Now let's multiply all of the y values by a negative 2. Okay, and let's plot those. So negative 5, negative 4, negative 4, negative 2, negative 3, 0, negative 2, negative 2, and negative 1, negative 4. And now you can see that we had a little bit of narrowing from the vertical stretch. We definitely shifted to the left 3, and then we reflected across the x-axis. It's very nice. And something else I wanted to mention. Do you see this point 0, 0 right here? And 0, 0 is now negative 3, 0. So you can see that transformation right there of that point. Okay, let's look at this next one. Looks like a lot going on here, but here we have the square root function. And so this is an error. This should say y equals the square root of x. And we have a vertical compression by 1/2, and then we have going to the left 2 and then down 3. That's what our new function g of x is transformed. Now, let's go ahead and put a few points on our square root function. Let me just change this color so I can stay with it. Y equals the square root of x. So we'll go ahead and just have 0. Whoops. We can't take the square root of a negative number. So 0, 1, 4, 9. Can't really go that much further. I'll just kind of go out to 16, okay? And then square root of 0, 0, 1, 2, 3, and 4, okay? So let's get this on here, and you can see that it looks something like this. So this is y equals to the square root of x. That's our parent function. Okay, now let's take a look at what happens. I'm going to do this one in purple. So how are our x values affected? So our x values are just taking 2 away. Now our vertical compression by 1/2 takes our y value and takes 1/2 of those y values and then subtracts 3 from them. So let's go ahead and subtract 2 from all of our x values. And now let's take 1/2 of y and subtract 3. So we'll work with that 1 point. 1/2 of 1 is 1/2, and then when you subtract 3, you're going to be at negative 2.5. 1/2 of 2 is 1 minus 3 is a negative 2. And then let's go to 4. 1/2 of 4 is 2 minus 3 is a negative 1. So that's probably negative 1.5. Okay, so let's go ahead and see what we have. Negative 2, negative 3, negative 1, negative 2.5, negative 2, negative 2. or 2, negative 2. That doesn't seem right. Oh, negative 2.5. Negative 1. So we have 2, negative 2. 7, negative 1.5. So now you can see that. And why was that a little difficult to graph? We had that compression, we had that vertical compression, which compressed it before the other transformations. So that's pretty neat. So this is our transform function, g of x. Okay, let's take a look at number 7. This is probably easier if we go ahead and write these coordinates. So negative 4, 0, negative 2, 2, 0, 0, negative 1, 1, negative 4, and 3, 0. And we'll just transform each one of these points. This is the graph of f of x. And now we want to graph g of x. And g of x is f of x minus 2. So we will be shifting the graph down 2. We will also take 2 away from every y value. So we have xy transformed to xy minus 2. So let's go ahead and start with the point negative 4, 0. Now if we take 2 away from that y value, we have negative 4, negative 2. And then negative 2, 2 will be now negative 2, 0. So we're just taking 2 away from every y value. 0, negative 2. 1, negative 6. And 3, negative 2. And we'll just kind of copy the shape of that graph. That last should have been curved a little bit more like that. Okay? So I'll write those down, 3, negative 2, and then this was 1, negative 6. Okay? Let's take a look at this one here in B. Let's do B next. So B shifts to the right 2. So what will happen there is we will have the same x and y values as above, but we will be adding 2 to every y value. Okay? So now, to every x value. So negative 4, 0 is now negative 2, 0. And then we had negative 2, 2. So that will be 0, 2. And we're adding 2 to every x value. We'll now have 2, 0. And then 3, negative 4. Whoops. And then 5, 0. So now we'll take on that shape, and there we have it. Now we have 2 transformations here. We're going to be going to the left 1 and up 2. So our xy values from our parent functions, we will take 1 away from the x value and then add 2 to the y value. Okay, so negative 4, 0 is now negative 5, 2. And the point negative 2, 2 is going to be negative 3, 4. And 0, 0 is negative 1, 2. Maybe write that coordinate later. And then we have 1 negative 4 is 0 negative 2. That we, yeah, 0 negative 2. And then that last point, 3, 0, take 1 away from the 3, it's 2, and add 2, so it's 3, 2. Then let's just let that curve like that. Okay? So that was very, very nice to show how those points changed with each one of those transformations. Last but not least, we're going to write equations for each one of these graphs. Now let's go ahead and write the parent function. F of x equals x squared. So what happened in graph A was it just went to the left 3. So f of x would equal x plus 3 all squared. In B, we went to the left 6 because our parent function is centered at 0, 0. So you can see how that point went from here to here. Now our 0, 0 point went to the left 6 and down 3. So f of x would be equal to, and it was also reflected across the x-axis. So we have the opposite of x plus 6 all squared minus 3. Okay? And I guess we could go ahead and write on each one of these. We originally had the point x, y on the parent function, and for the x values we subtracted 6, and the y values we subtracted 3. Over here, our x, y on our parent function, I think we also had a negative y here. There we go. In A, if we went left 3, we just subtracted 3 from every x value and left the y alone. Okay, the last problem in this practice, we'll go ahead and write what the parent function is, and of course you can see that this is the absolute value function. Okay, and here all we did was shift left 3, and we reflected across the x-axis. So our x, y values, we would have x minus 3 and then take the opposite of y. So we would write that as the opposite of the x absolute value of x plus 3. And in B, there was no reflection. We shifted to the right 2 and then down 4. So our x, y coordinates from our parent function added 2 to the x coordinate and subtracted 4 from the y coordinate. So that absolute value function, we would have the absolute value of x minus 2, and then we would subtract 4. And that concludes this class lesson.